we've developed a product line of both underduct and corrosion composites. Corrosion composites is the industrial water, wastewater product, and today we're going to emphasize the underduct product. Our staff has over 40 years experience both in manufacturing, sales, marketing. We have a rep organization all over North America, and we'll talk about that a little bit later as well. UnderDuct is really the best material choice for underground ductwork, for heating and ventilating. We say that as many buildings are now going to displacement ventilation, and when you bury a duct underground, it is very important that it doesn't corrode or leak. We offer both single wall and double wall. The facility where it's manufactured is over 90,000 square feet of building. That's not considering any of the outdoor space that's available. The single wall and double wall are probably equally sold as far as the market is concerned. The insulation value is the main reason for the double wall. Where do you find it? Just as an example, we've got airport terminals, auditoriums, automobile exhaust, aquatic centers, botanical gardens, churches, dog kennels, ground transportation centers, laboratories, hospitals, libraries, parking garages, etc. Looking at the photos, I'm going to point out where these jobs are. The upper left photo is the ground transportation center at Raleigh, North Carolina. The photo below that is a 6-foot diameter air duct that's bringing air into a hospital in Omaha, Nebraska. That was the first underduct job. The photo on the lower right is our VE duct, or vehicle exhaust duct, being installed at the University of Minnesota at Winona. Underduct advantages. It's corrosion resistant. Soils are typically acidic or caustic, and the fiberglass is not going to corrode or deteriorate underground. It's watertight. When the joints, sections are joined using the ASTM standard methods, you get a watertight joint. And if you have a sprinkler go off or a flood, the duct can be pumped out and there'd be no ill effects. Ease of use. It's shop fabricated to the maximum extent, creating as few field joints as possible. The factory assembled sections are lightweight, can be handled by a couple of men, and it doesn't require a crane on the job site. We have several different joining methods available. Underduct installation. This is a typical installation you're looking at. We recommend that it be set on a 4-inch bed of pea gravel or sand in a trench that has some drainage to it. If you look at the picture on the upper right, you'll see the register boots along the wall with the pink foam board on the back side of them for insulation. Our register boots are always single wall. All that duct is double wall at that particular project, the Davenport Library. And the lower picture is again a VE duct job, and that is also the University of Minnesota at Winona. All of our underduct has a C-veil on the interior and the exterior, which gives it a resin-rich surface, which prevents any leakage or damage to the structural layers. Shapes available. The shop has years and years of tooling for round. Round is a better airflow system, always less expensive, but we can make rectangular duct, oval duct, or whatever shape or transition required. We go from 2-inch up to 14-foot diameter. Ductwork typically doesn't get that large. The double wall is always sized by the ID, and the wall thicknesses are all governed by ASTM standards. ASTM D3982, PS 1569, and the SMACMA standards. And the wall thicknesses apply to both the inner and the outer shell on the double wall. Green Build. We're a member of the Green Build Council, and the duct has some great qualities that contribute to green building. Sustainable building, we have energy savings with the insulation. We have maximum airflow and efficiency because of that smooth wall. Resistance to mold, corrosion, leakage, moisture damage, low smoke, flame class 1 rating, flame and smoke. Long life, that's one of the issues that comes up in LEED points, longevity. Energy savings, allows for open concept in building design. Again, the displacement ventilation is a prime example. Laminated joints give you a completely sealed system. Most duct systems will leak somewhat. Ours will not. We feel that UnderDuct is the #1 choice for several reasons. The big one is corrosion resistance. As we mentioned before, can withstand the harsh environment, very wet corrosive systems where the water table may be up. And we feel it's a clear choice over stainless steel, galvanized PVC, PVC coated, or polyethylene. UnderDuct is designed and approved for direct burial. Does not require concrete encasement as with metal duct when buried in compacted sand or pea gravel. UnderDuct does not require hold downs as you would if you were trying to encase it in concrete. It won't bend, crush, or leak due to burial conditions. High strength to weight ratio. Filament wound composites are very strong, especially in the hoop direction, which gives us some excellent numbers with regard to strength for burial. If you think about the composites in general, the lightweight, high strength thing, vehicles, that's where they're going with it. A 20-foot section might only weigh 100 pounds, 200 pounds, and the guys in the job site can handle it. The photos you're looking at there, the one on the far bottom left is Sydney, Australia, and you'll see more of those photos a little bit further on. We tried to get a good mix of some of the photos from job sites. That's the water transportation terminal at Sydney. The one in the middle is the Myriad Botanical Garden at Oklahoma City. And the one on the right is, again, the Sydney Harbor terminal. This photo is of the Dublin Performing Arts Center in Dublin, California. This is an unusual job in that it's all rectangular. And there are several extenuating reasons for that, but it's a big auditorium, and you see the size of the duct from the man standing there. This is a rather unusual job. In the rectangular duct, especially the large stuff, we do recommend that it be concrete encased. Yes?
Does UnderDuct need to be concrete encased
for H20 loading? For H20 loading, UnderDuct, the question was, does UnderDuct need to be concrete encased for H20 loading? That would depend on the size of the duct, the burial depth, whether it's double wall or single wall, but we would typically do some calculating and let you know whether that can happen or not. And if it's under a concrete road slab, then the answer is no. Here again, you see the contractor setting up the duct, and in this case, they did all the fabrication even before they filled in underneath it. This, as the finished floor of the auditorium started to raise up, all of these UnderDuct outlets are going to be under the seating. So you get an idea of the complexity of some of the systems. Here again, the contractor is making some adjustments to some of these. The field adjustments are fairly easy to make in the field. Once the contractor is familiar with them, they have no problems. This job is Mercedes-Benz dealership, and this is the HVAC duct for the lobby of the dealership in El Dorado Hills, California. You can see they're putting two ducts in one trench, lowering it down. There's the same job again. The shop fabricated pieces that you see right there are on the left where the man is standing. That's a huge advantage. There are very few field joints. This is another job up in the Minneapolis area. It happens to be the Lakewood Mausoleum, and the contractor had set most of the duct. We paid a visit to the job site to assist them in getting started on the joints so that we could take these photos. And they had wrapped all of the joints to keep them clean with the plastic. So that's what you see the orange plastic for. This is the Eastern Avenue Library in Davenport. This was one of our first large jobs. And again, you're looking at a 36-inch diameter piece on the left-hand side. That was shipped out as one piece where the man is making the joint up at the far end. That's one piece that came from the shop. Here again, Eastern Avenue Library. See two sections that are coming up into the mechanical room. The plumbing fixtures are coming up. We coordinated all of the drawings with the plumbers and other utilities. This is a photo of the Ground Transportation Center at Raleigh, North Carolina. This is the Sydney, Australia. Again, if you look, you'll see that they put this in bedrock, right near the ocean. So their concern was salt water getting in, and it was a big concern. Here is the Sydney job again, and you can see the sandbags in the ditch. They were fighting high tides, and so on and so on. UnderDuct is an ideal product for this application. Now we're looking at the Kansas City Zoo. This is UnderDuct used in a aquatic situation, swimming pools, aquatic centers, zoos, where chlorine is in the air. It's an excellent product for using above ground. And this was the penguin exhibit at the Kansas City Zoo. Again, the Kansas City Zoo, you see the rectangular drops coming out and going through a wall. Material integrity. It's a filament wound product, and the resin and the glass are both inert. We don't have any metal tinfoil liner. We don't have anything there that could corrode or create a problem down the road. I mentioned before the hoop strength makes it very, very strong with regard to burial, and you'll see later the testing that we did exceeds any other product in that respect. Monoxivent UnderDuct products have been rigorously tested and approved by the International Code Council and meet the following codes. International Mechanical Code, IMC. International Residential Code, IRC. Uniform Mechanical Code, UMC. California Mechanical Code, CMC. This is, we spent the year 2012 going through testing and applications to get this ICC approval. So this is news as of November 1. We are tested and approved. UnderDuct is versatile. As you see, it can be used above ground, can be used below ground. We can make any kind of a fitting. The photo on the bottom right is the Myriad Botanical Garden. That's a round building. So the duct went around the perimeter of the building and all the takeoffs came up. The project required some pretty extensive SolidWorks drawings. The main trunk of that duct around the circle was 8 foot deep, and all the takeoffs had to come up the 8 feet and then over to meet very specific places. Sure. The question that just came in is, do we need to do anything for UV coating? If the duct is going to remain above ground, then the answer is yes. And we typically would gel coat it. And the gel coat has UV inhibitors, as well as color. But for buried duct, no, it's not required. This is the International Code Council, and this is our official approval that went into effect called the PMG, and our number is PMG 1171. Product has gone through rigorous testing and has surpassed the requirements of the existing code. These include flame and smoke spread testing, insulation value, water leakage, structural testing. Flame and smoke. The standard test for flame and smoke is ASTM E84. It's a tunnel test for how the flame would advance in a given size tunnel, both with and without ventilation. And the flame spread should be less than 25 feet, and the smoke development should be less than 50. And we've tested, and the ICC testing organization has tested, and we've passed that flying colors. The insulation value, this is one that's sort of hotly debated, but many of the codes now require for supply duct to be an R6 California requires R6. Many other states require R5. ASTM C518 test is the proper method for determining the amount of heat flow through a given material. We are tested and proven to be an R6 value with our standard 1-inch insulation. And that complies with California's 2014 requirements, which are the most stringent. Water leakage. Part of the ICC testing required putting the duct underwater and testing it. And what they ended up doing was submerging it 12 feet underwater, or the equivalent of, and tested it for 7 days with no leakage. So that's a testament to the fact that the UnderDuct will not leak. Structural testing. There's a test called ASTM D2412, and essentially, if you could envision a round duct section, maybe a foot long, being compressed. And what they want to know with this test is how many PSI, or how much weight, can you push down on it till you get 5% deflection. And so the ASTM procedures set up the test, and you go through all of this. And 8 PSI is what is listed in the testing requirements for buried duct. We were up to 30 times that for strength. And again, it's a testament to the filament wound structural fiberglass. And last but not least, here's our contact information. These are the UnderDuct websites. We have several phone numbers, including a toll-free number. But most important, we have the rep organization all over North America. And we also have just in the last few days hired a Western regional manager. We have a national sales manager, Mike Murphy, out of the Detroit area. We have now Daryl Fetter in the Western region, and we have Jim Wishusen operating out of Florida. So we're spreading out, and but the contact through the office here will get you through to anyone we need to. Are there any other questions that we haven't answered? I'd like to thank everyone for listening. And I hope you can go to the website and view this again if you would like to.